Okay, this is the final lesson portion of day 2 on limits. We're going to look at limits as x approaches infinity. Okay, so to find the limit of a rational expression, where we have f of x over g of x, as x approaches infinity, and f of x are designated as polynomials. The method they're suggesting is that we divide both the numerator and denominator by the highest power of x that occurs in the denominator and use the fact that the limit of 1 over x as x approaches infinity is 0, and the fact that the limit of 1 over x as x approaches negative infinity is 0. So what we're looking at, here's the graph of 1 over x. And as x gets really big and approaches infinity, our y value is getting really close to 0. Likewise, as x gets really close to, or really close to negative infinity, our y value is getting close to 0. Okay, so let's take a look. The limit as x approaches infinity of 3 minus x over 4 plus x squared. All right, x squared is my highest degree term in the denominator. I'm going to divide every term in this rational expression by x squared. So I'm going to get 3 over x squared, maybe, minus x over x squared, which is 1 over x. In the denominator, 4 over x squared plus 1 over x minus 1. Okay, now we know 1 over x or 1 over x squared, in either of those cases, the term is going to get closer and closer to 0 as x gets very large. So each one of these terms is going to become 0. And so the limit let me back that up. So the limit of this expression turns out to be 0 over negative 1, which is 0. Okay, let's take a look at number 29. The limit as x approaches infinity. We've got a 4th degree and a 3rd degree. I'm going to choose to divide by the highest degree in the denominator. Some people would do the highest degree overall. It really doesn't matter. But let's take a look. The limit as x approaches infinity of, this would turn out to be 4x. I'm dividing by x cubed everywhere. Plus 5 over x squared plus 1 over x cubed. I'll do that cubed in just a second, maybe. There we go. And then we're going to have 37 minus 9 over x cubed. Okay. Every term that has an x in the denominator is going to go to 0 if I let x become a really large number. So here I'm left with the limit as x approaches infinity of 4x over 37. Okay, well, that's a linear function. Not very steep, but it's a positive slope. And in the end, this function is going to go to infinity. Okay, final question here for this slide, number 30. The limit as x approaches infinity of a cubic over a cubic. Okay, so I'm going to divide every term by x cubed. The limit as x approaches infinity of 1 minus 4 over x plus 7 over x cubed. That's the numerator. 3 divided by x cubed in the denominator minus 6 over x squared. Not sure why I can't write my exponents very clearly. Minus 2. Okay, remember, as x goes to infinity, all these terms with an x in the denominator will get very small, very close to 0. So in the end, I'm left with 1 over negative 2. Okay, now taking a look at these three examples, in the first problem, number 28, we had a degree 1 in the numerator, a degree 2 in the denominator. And in the end, we got 0. In number 29, we had a 4th degree in the numerator and a 3rd degree in the denominator. So larger in the top than in the bottom. And this one went to infinity. Number 30, we had same degree in the numerator and denominator. And this resulted in a 1 over negative 2. All right, so taking a look and generalizing, when the degree of f of x, the numerator, is less than the degree of the denominator, the limit as x approaches infinity of f of x over g of x will always be 0. Okay, when the degree of f of x is equal to g of x, the limit will equal the ratio of the leading coefficients of the dominant terms. Okay, so this happens in number 30. Right? Where we have 1x cubed over negative 2x cubed, and we got the leading coefficients. When we had f of x less than g of x, the degree of f of x is less than g of x. This is like example number 28. Okay, x over x squared. All right, the last one, when f of x's degree is greater than g of x. Okay, this is like example number 27. All right, and in this case, our limit will either equal positive infinity or it could equal negative infinity, depending, okay, on what your function looks like. Okay? All right, moving along. See if we can get through this one more slide. So we're just practicing limits at infinity. For every one of these, we want to let x get really, really big. Let's see if we can apply our rules or generalizations that we saw on the previous page. So the degree of the numerator is 1, the degree of the denominator is 1. What did we say happens when the degree is the same? We said we get the leading coefficients. So the answer to this one is just 2 over 1. Okay, number 32. The limit as x approaches infinity. This time we have polynomial over polynomial. Degree of numerator is less than the degree of the denominator. Okay, what do we say happens if the degree of the numerator is less? Oh, it always goes to 0. Let's think about that. If I do the divide by the largest power, we're going to get 1 over x, 2 over x squared. Minus 3 over x cubed all over 2. All right, all these are going to 0. We're left with 0 over 2. Okay, so we got a 0. So degree of the numerator is less than the degree of the denominator. You're going to get 0 no matter what. Okay, this time, degree of the numerator is less than the degree of the denominator. What happens? No work required. That's going to be a 0. Okay, 34. Degree of numerator, degree of denominator, exactly the same. Our limit is the leading coefficients. Negative 2/3. Okay, 35. The degree of the numerator is bigger than the degree of the denominator. Also, note we're going to negative infinity. Okay? All right, well, let's see. What if I divide everything by x? I'll get x squared minus 5 over x, 1 over x minus 1. Okay, I know this goes to 0. I know this goes to 0. So in the end, I'm really kind of just looking at the limit as x approaches negative infinity of x squared over negative 1. So I'm just going to call it negative x squared. Okay, that's this parabola going downward. So as x approaches negative infinity on this function, y approaches negative infinity. Okay, last one. Degree of the numerator is less than the degree of the denominator. Oh no, I got tricked. The degree of the numerator is the same as the degree of the denominator. All right, so we're going to get negative 4 over 2 or negative 2. Okay, in the last slide, I would like you to do these examples, find the limit as x approaches each of these a values, find the limit as x approaches infinity, and find the limit as x approaches negative infinity. And then we can go over the answers and see how you did. The end of day 2.